Dear students, today we will discuss the chapter Inverse Laplace Transform. We have already studied Laplace transform. There we have seen that Laplace transform of a function f of t is a function of s. Here, in case of inverse Laplace transform, if L of f of t, Laplace transform of a function, is a function of s, then f of t can be written as L, you bring this L to the other side, 1 by L, or you can write it as L inverse of f of s. It's a reverse process, like differentiation and integration. If Laplace transform of f of t is a function of s, then this function, which is L inverse of the right hand side, is called as inverse Laplace transform. So we derived some of the formulae in Laplace transform. So that is Laplace transform of 1 is 1 by s, Laplace transform of e power at is 1 by s minus a. Now what I will do is I will write the same formulae in the reverse order. So first I will write f of s, then I will write its inverse. F of t, it is actually L inverse of f of s, inverse of this function. So now if I write here 1 by s, so we know its inverse is 1, because Laplace transform of 1 is 1 by s, therefore inverse of 1 by s is 1. Then 1 by s minus a, we know that it is Laplace transform of e power at. 1 by s minus a is Laplace transform of e power at. Therefore inverse of 1 by s minus a is e power at. If it is in place of minus, if we have plus, then it is e power minus at. Similarly, we have 1 by s square plus a square. So in fact, Laplace transform of sin at is actually a by s square plus a square, right? Therefore inverse of 1 by, in place of a we have 1 here, so 1 by s square plus a square will be sin at. So this a I should write in the denominator here, so sin at by a. So inverse of 1 by s square plus a square is sin at by a, remember this. Similarly, inverse of s divided by s square plus a square. So we know that this is Laplace transform of cos at. Therefore inverse of s by s square plus a square is cos at. Similarly, we have, if f of s is 1 by s square minus a square, then its inverse is a function of t, that is sin hyperbolic at by a. It's a function of t. So this is the inverse of 1 by s square minus a square. Similarly, inverse of s by s square minus a square is sin hyperbolic at. This is cos hyperbolic at. Cos hyperbolic at, because Laplace transform of cos hyperbolic at is s by s square minus a square. Then inverse of 1 by s power n, inverse of 1 by s power n is t power n minus 1. Remember the formula in the reverse direction here, because we know this Laplace transform of t power n is n factorial divided by s power n plus 1. Here I wrote 1 by s power n instead of n plus 1. That means you have to replace n by n minus 1. Therefore Laplace transform of t power n minus 1 will be n minus 1 factorial divided by s power n minus 1 plus 1, 1 cancels n. Yes. So t power n minus 1, Laplace transform of t power n minus 1 is n minus 1 factorial by s power n. Therefore 1 by s power n keep here, function of s, then bring this n minus 1 factorial to the other side. So then what you will get, inverse of, L inverse of, so bring L to other side. So L inverse of 1 by s power n is n minus 1 factorial here, and this t power n minus 1 in the numerator. So t power n minus 1 by n minus 1 factorial. So you must remember in the reverse order, if the function of s is 1 by s power n, then its inverse is t power n minus 1 by n minus 1 factorial. Now just recall the first shifting property. What that property says, if Laplace transform of f of t, this one we studied in our previous concept, Laplace transform, it's a function of s. Laplace transform of f of t is a function of s. Then Laplace transform of e power at times f of t is a function of s minus a. So this is known as the first shifting property. So what is f of t here? f of t will be L inverse of function of s. If L of f of t is f of s, then f of t is L inverse of f of s. Then e power at into f of t into f of t will be L inverse of f of s minus a. That means L inverse of f of s minus a is e power at into f of t. So what is f of t? L inverse of f of s. So from this we obtain this. Therefore L inverse of function of s minus a will be equal to e power at times f of t. F of t is what? L inverse of f of s. L inverse of f of s. Remember this. If you want to find L inverse of function of s minus a, write it as e power at times L inverse of f of s. In place of s minus a, replace s and its inverse. Write its inverse. So example, we know that Laplace L inverse of 1 by s power n. What is L inverse of 1 by s power n? T power n minus 1 by n minus 1 factorial. So Laplace transform of L inverse of 1 by s power n is t power n minus 1 by n minus 1 factorial. Suppose you have in place of s minus a, then what is L inverse of 1 by s minus a power n? That means we have function of s minus a. So 1 by s minus a power n, it's a function of s minus a. Then what we should write? This we should write as e power at into L inverse of f of s. If this is your f of s minus a, then what is f of s? F of s is 1 by s power n. This is f of s, this is f of s minus a. So 1 by s power n. Therefore this is equal to e power at into L inverse of 1 by s power n is t power n minus 1 by n minus 1 factorial. So remember this. It's very important to remember. If inverse of 1 by s power n is t power n minus 1 by n minus 1 factorial, then inverse of 1 by s minus a power n is s minus a. In place of s we have s minus a, then we should multiply this by e power at. That's all. E power at into t power n minus 1 divided by n minus 1 factorial. So remember this point.